We are given two complex numbers, z1 and z2, and we're asked to express them in this form first, and then divide z1 by z2 and raise it to the power of 6 in terms of the constant a that is given to us in this complex numbers here. So the first thing we do to get it in this form, to get both of them in this form, we have to find the modulus, and the modulus is found by doing this squared plus, so the real part squared, plus the imaginary part squared. And the square root of 3 squared is obviously 3, so this part is 3a squared. That's the modulus for z1, and the modulus for z2 is going to be the square root of 1 squared plus 1 squared, which is the square root of 2, right? Minus 1 squared and 1 squared is the same thing, because the imaginary part is minus 1. Then from this we find that the modulus of z1 is 2a, because it's 4a squared. The next step is to find the argument in order to get it in this form, so the theta, the angle. And I always like to do it by drawing a diagram, and you just have to work with a constant a because we're not given the actual number here. So we say, okay, the reals go on this axis, the imaginary numbers go on this axis. So we have a here, and we have a square root of 3 here. And we know that this here is 2a. And we need to find this angle here, theta. This angle we're going to find, imagine this is just a triangle, right? And so we have a square root of 3, and 2a. And this is the theta. The theta we find by going, okay, sine of theta is going to be opposite over hypotenuse, so a square root of 3 over 2a. Don't be intimidated by the constant c, because it just falls out, and it's going to be square root of 3 over 2. And from your trigonometry knowledge, you should know that the theta is therefore 60 degrees, because sine of 60 is square root of 3 over 2. There are ways to find this out, for example, the triangles, if you remember that this is what a triangle should look like. And I always remember the square root of 3 is next to the 30 degrees, so since this is 90, this angle has to be 60 degrees. So you know that SOHCAHTOA, for this, using SOHCAHTOA for this triangle, opposite over hypotenuse, is going to give you 60 degrees. That's how I memorize it. So the argument of z1, the angle in the cis, in r cis theta, is 60 degrees. So now we know that z1 actually looks like this. This is our argument, and then we have cis 60 degrees. Now we need to find the argument for z2. That we're going to do by saying, okay, the real is at 1, the imaginary is at -1, and so we need to find this angle here. Alternatively, you could go this way around, it doesn't really matter. This angle here we find by saying, okay, we have another triangle now, and the sides are 1 square root of 2, and so from your trigonometry knowledge, you should know that these two are 45. And so the argument of z2 is 45, and so to write z2 in cis form, so if this is z1, then z2 in cis form is going to be the modulus is square root of 2, so r is the modulus square root of 2, cis 45 degrees. Next thing that we're asked to do is go z1 over z2 raised to the power of 6, so I'll just move down, I need space, I write big. And so we go z1 over z2 to the power of 6. You really can't divide these. What we can do, however, is expand them and then use de Moivre's theorem to eventually raise them to the power of 6. So instead of writing them in this form, we can also write z1 is equal to, so the modulus times cosine of 60 plus I sine 60, and z2 is square root of 2 cosine 45 degrees plus I sine 45 degrees. Sorry for the handwriting. And now De Moivre's theorem says that to raise something to the power of 6, you just raise the modulus to the power of 6, and then you put in 6 in the angles. And so this is actually convenient because what we have to find is z1 over z2, so this is actually what we have to raise to the power of 6. And so we raise this, the numerator to the power of 6 and the denominator to the power of 6, and this then becomes 2 to the 6, 8 to the 6, right? Cosine 360, notice it nicely falls out, or it is going to become a nice number, plus I sine 360 degrees, that's our z1, and then z2, which is the denominator, is going to be square root of 2 to the power of 6, cosine 270, because 45 times 6 is 270, plus I sine 270 degrees. And now this is all going to fall out really nicely, as you're about to see. 2 to the power of 6 is 64, so we have 64 a to the 6, cosine of 360 is 1, and sine of 360 is 0. So the I falls out in the numerator, so you get this. In the denominator, we get square root of 2 to the power of 6 is 8. There is no a here, that's nice. Cosine of 270 is 0, and sine of 270 is minus 1, so we get minus 1. And then notice this is going to fall out nicely too, so you know you're on the right track. This is going to become, and the 1 obviously goes away, this is going to become minus 8a to the 6 over I. And that is your answer to this problem here. We have given it in terms of a and I.